Okay, right, let's get started. So, question 13 is on course year 2018-2019. So we have 13A and 13B. I'm going to start off by doing 13B first, okay, because this is the latest information that we learned. So table 1 shows rate constant. Okay, highlight informations that are given in the questionnaire for the decomposition of N2O5 at two different temperatures. Okay, so it would be good if you label T1 as T1, correspondingly K1, T2, and correspondingly K2. Okay, so first question, determine the activation energy for this reaction in kilojoule per mole. So how are you going to determine activation energy? When you have K1 and T1 value with K2 and T2, you are going to use K1, ln K1 over K2 equals to EA over R multiplied by 1 over T2 minus 1 over T1. So this is quite straightforward. All you have to do is that make sure you substitute correspondingly and make sure you remember that temperature must be in Kelvin. So please plus 273 to the temperature given in degrees Celsius. All right. Now, I would like to remind you that please don't do this. Okay, I have students who do this. Okay, dia tolak. Selepas tu, what would you get if you do this? Can you give me an answer, please? 1 minus 1 over 35 minus 1 over 25. Can someone give me an answer to this?
Negative 2 over 175.
Negative
Negative 2 over 175.
2 over 175. Then from here, plus 273. No, please don't do this. This doesn't work like that. So for activation energy, this would be your long answer, right? And round it off to 2 decimal place. So I hope all of you are copying this, huh? Right. Now for question B2. Activation energy can be also determined graphically. So please recall, under Arrhenius equation, we saw determining activation energy using calculation, that would be this. And we saw activation energy determined graphically. So that is from the original equation, we make it linear. So sketch the graph and explain briefly. So all you have to do is that you write out the equation that has been linear. You don't have to show derivation. So this is the equation that was linear from the original equation. Okay, so match it with y equals to mx plus c. Show the graph, sketch the graph. Make sure you label correctly. Okay, so start off by saying the Arrhenius equation is k equals to a exponential negative EA over RT. Taking natural log on both sides will give this equation over here. Rearrange the equation to match y equals to mx plus c by plotting ln k against 1 over t temperature. The activation energy can be calculated from the gradient value. So this is how you write your answers. Okay, because you're describing briefly the steps that you do in order to get the graph. Okay, everyone? Is everyone okay?
Yes, madam.
Yes, madam.
Right. Okay, no problem. Huh? So,
Okay, madam.
okay. Now let's look at question 13 pula. A. So question 13A, the heating of dinitrogen pentoxide decomposes as following. The reaction is first order, it's already given to you. With respect to N2O5. Determine the rate of formation of oxygen. So you can see here, I have already written it in a mathematical form. This would be rate of formation of oxygen. If the rate of disappearance of N2O5, so this is the rate of disappearance of N2O5. Okay, is given to be 1.25 times 10 to the power of negative 2 molar per minute. So now these two species, where do you find these two species? You would find it in the differential rate equation. So the first thing to answer this question would be to write your differential rate equation. So how do you write your differential equation? Rate equals to negative for the reactant, and the stoichiometry must be 1 over 2. Okay, change in concentration of N2O5 divided by time equals to a positive change for products, and again 1 over its stoichiometry. Change in concentration of NO2 divided by time equals to positive change in concentration of oxygen divided by time. So this is your differential rate equation. So from here, I will be extracting out the given information, which is from this part, okay, and the information that we are required to find, which is this. So we are going to make an equation by just using that two that we have extracted out from the main equation. So as you can see over here, I've written it. Now I'm going to substitute in the corresponding value. When I substitute in the corresponding value, I have removed the sign. Okay, so the final answer for the rate of formation of oxygen would be 6.25 times 10 to the power of negative 3 molar per minute. Okay, how did I get molar per minute instead of the usual molar per second? Go back to the question. Okay, the rate of disappearance of N2O5 is given to be in molar per minute. Therefore, the rate of formation of oxygen should be also molar per minute. All right. So if you are unsure, if you are feeling, do I have to include the sign or do I not have to include the sign? I have told you, you can always do a concluding remark, which is right. Rate of formation of oxygen equals to 6.25 times 10 to the power of negative 3 molar per minute. If you are unsure or semi-confused whether there's a sign or not. Okay? So this will make sure you get your full marks. Are we good, everyone?
Yes, madam.
Is everything okay? Can you follow?
Yeah.
Yes, madam.
Okay, madam.
Okay, right. So now let's look at the second question on A, which is calculate the rate constant. I would encourage you to write it with the correct alphabet. For this reaction, 25% of N2O5 is decomposed within 10 minutes. Now you have to transform this into a mathematical sentence. So let's do that. Again, they said constant for this reaction is 25% of N2O5 is decomposed within 10 minutes. Okay. So I've actually written it out so that I can understand better. Now what we had was the initial concentration. Okay. So initial concentration changing into a concentration which is after minusing 25%. Initial concentration minus 25% of it, right? Because they say it decomposes by 25%. It gets into another concentration and all this happens in 10 minutes. So we have transformed the statement into a mathematical information. So now you can actually put in any values to begin with, but just that you match the accordingly with the percentage lah. Tetapi the easiest way is to assume that the initial concentration is 100 since it's percentage. So after 10 minutes, it would be 75% because 25% telah decompose. Okay, and all this is happening in 10 minutes. So since it is a first order reaction, in order to find the rate constant, we can actually use the formula ln initial concentration minus ln concentration equals to Kt. Substitute in correspondingly. Make sure you're not doing it inversely. So you get the value of K. Okay. So the value of K here is given in 2 decimal place, but when you press your calculator, you would actually get this long answer over here. All right, so please save this long answer. Why? Because the last question was asking you to calculate half-life. So half-life for first order, again, you have to hafal your formula, which is ln 2 divided by k. Half-life for first order is ln 2 divided by k. Substitute in the long value over here. Okay, don't substitute in 2.88. You will get a slightly off answer for your time, right? So make sure to substitute something that is a 4 decimal place into this equation, and you'll get your time. Don't forget your unit. Very important. Okay. Now let's look at another question. Question 14. This is on initial rate method. As you can see, there is data given already to you. So now, data for reaction of methyl ethanoate and hydroxide ion at a certain temperature is shown in the table. So determine the order of reaction with respect to each reactant. So you have to use the initial rate method. Now, before you begin the initial rate method, you must write out the general rate law. So I'm going to rewrite it back here. So the general rate law for this reaction would be rate equals to rate constant multiplied by what reactants we have in the question. So we have 2 reactants, and they must be raised to a certain power. So I'm going to use M and N. Those are the orders. Okay. So next, what we are going to do, we are actually going to compare, right? Even before we do calculation, because this is a 9-mark question, you have to show calculation, right? Can you see that you have to first choose which 2 experiments you are going to use? So make sure you choose experiment that has one of the concentration constant and the other one changing. So I'm going to choose experiment 1 and experiment 2 because in this experiment, I'm having the concentration of CH3, COO, CH3 constant, whereas the concentration of OH minus is increasing. And the next part, in order to find the order of reaction for the methyl ethanoate given, I'm going to choose experiment 2 and 3 because in that experiment, the concentration of OH is constant. So let's do that. So I'm going to start by writing rate 2 divided by rate 1. Okay, let's comparing experiment 2 and 1. So rate 2 divided by rate 1 will be equivalent to K multiplied by concentration of COO, CH3 for experiment 2 and concentration of OH minus for experiment 2 divided by K CH3, COO, CH3 concentration for experiment 1 and concentration of OH minus for experiment 1. All right. So now, since the concentration of CH3, COO, CH3 is the same, we can cancel that. And the value of K will also be the same. So what we have is rate and the concentration of OH minus. So let's write that. So rate 2 was 1 point. Can someone do the calculation for me, please? Press your calculator. Divided by, oh, sorry, terbalik. Okay, don't do that mistake. These are the common mistakes because you are rushing in exam, but still keep your eyes open and substitute in the correct values. Equals to 0.154 to the power of n divided by 0.12 to the power of n. So can you solve this for me, please? What is on the left-hand side?
1.285.
1.285 times 10 to the power of
No, madam. No times.
No power. Okay. Right. 1.285. Now, what about for the other part? If you
One
have
point
just,
two eight three, madam.
okay, equals to 1.283 raised to the power of n. Correct?
Yes, madam.
Okay. Therefore, what can you say? N equals to 1 lah. I don't have to divide it. It's approximately 1. All right. So, if you leave your answer here, you won't get full marks. So you have to conclude the answer by saying the order of reaction with respect to OH minus is first order. Okay, so we are done for the first reactant. Now let's do for the second. So second, we are going to compare experiment 3 and experiment 2. So start off by writing rate 3 divided by rate 2 equals to K, again CH3, COO, CH3 for experiment 3 to the power of M multiplied by concentration of hydroxide, experiment 3 to the power of N divided by K. Okay, it looks like a very tedious process, but yes, please do it. Okay, your goal is to get maximum marks for exam. Therefore, please show. This is just once in a lifetime run, right, for exam. Okay. So now in this case, what is same is the concentration of OH minus will be the same. Therefore, and as well as K value, you can cancel that. So now substitute in the corresponding value, 3.4, 2.03, okay. So 3.4 times 10 to the power of negative 3 divided by 2.03 times 10 to the power of negative 3 equals to, what is the concentration? It would be 0.84. Can you see there's a mistake here? It's 0.084, not 0.0. So 0.084 divided by 0.05. Answers, please.
1.675.
675. What about here, Tanish?
1.68, madam.
1.67?
1.68, madam.
1.68. Okay. So here also we can see that N is equivalent to 1. Right? So conclude your answers by saying the order of reaction with respect to CH3, COO, CH3 is first order. Okay, so both of them are first order lah. So from there, what was the next question? You are required to write the rate law. So question 2, now that you know the order, we can write a complete rate law, which is, okay, if you don't want to put the power of 1 also, no problem. Okay, I just want to put it because I want to show off my calculation. All right. Okay. Next question. Calculate the rate constant. Right. So now, in order to determine the rate constant, you must know what order of reaction is this. So what order of reaction is this? What is the
Second
order?
order, madam.
Second order. How did you get that, Tanish?
Overall order, madam. 1 plus.
Yes, please remember, this is important. Okay, don't get confused. When the question is asking calculate the rate constant, you must look at the overall order. Okay, bukan order based on CH3, COO, CH3 or OH minus. It must be based on the overall order. So overall order, how do I get overall order? It is 1 plus 1. It would be 1 plus 1, huh? Right, so that's second order. So in order to calculate the rate constant for second order, you can use the integrated rate law. Can you use the integrated rate law? What formula can you use?
Madam, I just used the diploma.
You just use the rate law, okay? Right? You just use the rate law. You don't have to use the integrated rate law. Kenapa tak boleh guna integrated rate law? Do we have initial concentration? Do we have sorry, a final concentration? Do we have time? No, we don't have all that. So what you can do, you can just use this. Okay, we can just use this equation over here, right? Untuk cari rate constant. So please remember, rate constant kita boleh cari guna rate law dan juga integrated rate law, right? So I know most of the time the examples we do memang guna integrated rate law, tapi kadang-kadang there is no option, okay, to use the integrated rate law, so we can just use our basic rate law. So sekarang ni we have 5 data over here, right? So 4 data over here. So you can just choose one of the data and substitute in correspondingly to find rate constant. So I'm going to use the first data. So rate for the first data was, what was the value of rate? 1.58 times 10 to the power of -3 equals to K. What is the concentration of CH3COO3? COOCH3? 0.05 multiplied by concentration of OH minus was?
0.12.
Sorry?
0.12, madam.
0.12. So what was the answer for K? 0.263. Right. So it is per molar per second because this is second order. So please take note of that. Right. So let's look at the final question. How many times the rate will increase if the concentration of both CH3, COOH3 and OH minus is doubled? So for this, we actually have a working. So the first rate, okay, the first rate was this. Okay, the initial situation was this, to the power of 1, and the concentration of OH to the power of 1. So now we have a second situation whereby the concentration of both the species is doubled. Okay, so that's how you write it. You're doubling the concentration. So you put a 2 in front of the species inside the square bracket. So now what we are going to do is that we are going to try to match this with the first equation. So how do I do that? I have to bring out my 2. Okay, so that would give me rate for experiment 2 to be 4 times K multiplied by concentration of CH3, COO, CH3 and concentration of OH minus. So as you can see here, this part here matches with this. So I can replace it by writing 4 times of rate 1. So from here we have our answer. That is, how many times the rate increases when I double the concentration of reactant? The rate increases 4 times or 4-fold. Okay? When concentration of each reactant is doubled. Okay? Okay, let's continue with question 14b. So 14b here, it says, the decomposition of ammonia to N2 and H2 was studied on the surface of tungsten and osmium catalyst. Okay, profile diagram is shown. You can clearly see from the diagram that osmium has got higher activation energy compared to the reaction with tungsten. So now, which catalyst is better for this reaction? Explain. So which one do you think is better for this reaction? Osmium or tungsten?
Tungsten.
Tungsten, right? Semua orang boleh follow? Tungsten is better. Why? Because How do you write this? Because the activation energy, okay, please write in full. I'm writing short form here. Because the activation energy is significantly lower compared to the reaction using osmium as catalyst. Okay. Therefore, the rate of reaction will be higher with tungsten as catalyst. Can you see that? This is how I would have answered if I was a student. Okay, you have to give a complete answer. Right? Are we good? Boleh nampak semua orang? So now, the next thing is that calculate the activation energy. Oh no, sorry. The activation energy for the above reaction is given to be 163 kilojoule per mole. So how many times faster would this reaction be if the temperature is increased to 550 degrees Celsius? So when the question is asking about how many times faster, what we are going to do is that we are going to compare K. Okay, we are going to compare the rate constant because the rate constant is directly proportional to rate. So let's find the rate constant for the first and the second. Actually, we can do this together by using the ln K1 over K2 equals to EA over R 1 over T2 minus 1 over T1. From here, we will get the ratio of K1 over K2. So from there, we can find out. So let's substitute in the corresponding value. Now, what is the rate constant for the first one and the second one? We don't know. Never mind. So this is just going to be ln K1 over K2 equals to activation energy 163 times 10 to the power of 3. Now, this is, please remember this. It's kilojoule per mole. Pastikan tukar kepada joule in order to do calculation, divided by 8.314, 1 over T2, I would give it to 550 plus 273 minus 1 over 450 plus 273. Now, can I get jawapan, please? Is equivalent to ln K over 2. So, can you shift ln for me, please? Can someone shift ln and give me an answer? Okay. So now you can see that the ratio between the first and the second rate constant is 0.0371. Okay. Now the question is not asking for ratio. What is the question asking? The question is asking how many times faster. Okay. So in order to know that, let's assume the first value here, okay, the rate constant for the first reaction here is 1. Okay, so if the rate constant for the first reaction is 1, we should be able to identify what would be the rate constant for the second reaction easily. And we can directly see berapa kali ganda, how many times it is increasing. So I'm going to put 1 over K2 equals to 0.0371. Therefore, what is the value of K2? It will be 1 divided by 0.0371. So what is it? So it would be 26.95. So this is approximately 27. So how many times is the reaction increases? The reaction increases 27 times. Okay, conclude your answer. Boleh? Is it clear how to do this kind of question?